Hello, everybody, and welcome back to another episode of Maths Made Easy. In the previous episodes, we've looked at the Argand diagram and some simple complex number arithmetics. In this episode, we will be looking at further examples on addition and subtraction and representing these complex answers or complex number answers on the Argand diagram. So, let's proceed. I would suggest that you get a book with a pencil or paper and to follow up, because at the end of this episode I'll be giving out an exercise for you, something for you to try on, and the answers will be revealed. So for the first example, we have z1 plus z2, and remember we've been given the values of z1 and z2 to be 2 plus 4i and 3 minus I respectively. So z1 plus z2 is going to be 2 plus 4i plus 3 minus I. Now notice here that I'm adding brackets. This is because this sign outside is going to affect the second sign inside, as we would see in the second example, which is the B part. So what we're supposed to do here is to add the two real parts of both complex numbers, where we have 2 and 3, which is going to give 5. And as for the imaginary part, we have 4i minus I. Now 4i minus I, that's 3i, and it's positive, not negative, so it's going to be plus 3i. To understand what I did clearly here, just try and represent them on the number line. Where you have 0, and wherever you have 4i, which is around here, when you subtract I, that is, when you subtract it with 1, it's going to give you the next number in the line, which is 3. So that's our final answer for the A part. For the B part, we have z1 minus z2. z1 minus z2. z1 is 2 plus 4i and z2 is 3 minus I. Oh, sorry, subtraction. Minus 3 minus I. So this is one complex number, and this is another complex number right here. So to subtract the first one, to subtract this from this, all we do is 2 minus 3. Those are the real parts of both complex numbers. 2 minus 3, that will give you minus 1. And here we have 4i minus I. But you have to give preference to this negative sign right here, because it's going to affect what is inside here. Now when you open this bracket, what you would have is minus 3 plus I. So this becomes 4i plus 3i, rather than the usual 4i minus I as we have it there. So the answer is going to be 4i minus 3i, that's going to be 4i plus 3i, that's going to be 5 plus 5i. That's the answer to the second one. And for the third one, we have z2 minus z1. C part, z2 minus z1. z2 is 3 minus I, and z1 is 2 plus 4i. Now what's in between them is subtraction, so we're subtracting z1 from z2. Now the real part we have 3 minus 2, that's 1. Or to use the colors, the real part are 3 and 2. The answer of both is 1. Here we have minus I minus 4i. The reason why I say minus is because of this negative sign outside. It's going to change everything inside the bracket because it's multiplying everything. When you open up the bracket, you're going to be having minus 2 minus 4i. So when you come back to the whole expression, you'll find out that it's going to be minus I minus 4i, which gives you minus 5i. Hey, it's like I've solved this before. Oh, so this is minus 5i and this is plus 5i. So that's the three solutions to the arithmetic of the three complex numbers. Now we have to represent these three answers on the Argand diagram. We have 5 plus 3i. The first thing we do is locate where 5 is on the real axis, which is around here, plus 3i, and 5 plus 3i, and on the imaginary axis we have 3i, which is somewhere around here, and 5 here. So they intersect here, which is our complex number 5 plus 3i. Draw it to the origin O or 0, and that's the representation of the first one. For the second one, we have minus 1 plus 5i. Minus 1 is here on the real axis, and 5i on the imaginary axis is around here. So this is minus 1. So this will be minus 1 plus 5i as our second complex number. And for the third one, sorry, this is supposed to go through to the origin and not intersect this line. I'll redraw it in a bit. For the third one, we have 1 minus 5i. So the real number is 1 and the imaginary number is minus 5i. We have 1 and minus 5i somewhere around here. So this is the point, 1 minus 5i. So this is how to represent complex numbers on the Argand diagram. As for the exercises, I want you to try this out. I want you to evaluate A, 5 plus 2i minus 3 minus 2i, and B, minus 2 plus 6i minus 3 minus 2i. So the answers to these will be for the A part we have 8 plus I and minus 5 plus 8i as the B part. So with this we come to the end of addition and subtraction of complex numbers. Next we will be looking at multiplication and division of complex numbers. Thank you for listening and have a good day.